Welcome to my operating systems comparison presentation. This presentation is for my operating systems final report. In this presentation, I'm going to break down 8 different operating systems, describe them, talk about each one, and compare them. There's going to be 2 different groups, which I will talk about in the next slide. And after I compare each group together, I'm going to do my final thoughts on each system and talk about what I think are best useful. The first 3 systems in the group are Windows, Macs, and Linux. I group these together because they are similar, and the other 5 operating systems aren't really similar. Some of the systems are built into Windows, Macs, and Linux, so I'm just going to compare the 3 of them. Talk about what they each are good in or downsides. And with the second group of 5, a batch timestamp, distributed, embedded, in real time, I'm going to do the same, talk about what each of them are, what they are good at, what some of their flaws are, and compare them. So Windows? The Windows operating system is a very versatile system. It is great for many types of jobs, many types of hobbies. You can use it for gaming, graphics, really anything. You can customize your system. Your systems can just be customized very heavily. They can do so many things. They have a graphics user interface or GUI. Makes it so you can just see what you're doing. You can have graphics, images, everything. It's a very affordable up to entry level, so just a basic. You don't want to do anything fancy. You just want the basic system, or you can get very more versatile and expensive. But Windows does have 95% of the malware and viruses. So you gotta be more careful when using this system, and it's not as stable as a Mac or a Linux operating system. Okay, now Mac. Mac is it also features GUI. It was the first one to really use it. They were also first to really include internet over system, file sharing, and more features like that. Macs are also very easy to learn and use. Mac also allows their users to use Mac, Windows, and Linux apps all on one Mac, which is a lot more. You can just get one and you can do more than just if you want everything, it's just all in one place. There's also less viruses on the Mac. It's more expensive on the entry level. Like if you want just the basic Mac, it's going to be a lot more. It's a lot more fixed price. You can't. There's a lot less mix and matching than with Windows. So Linux directly manages the system's hardware and resources. It's a connection between the hardware and software. It's a very hands-on option, and by that I mean it's not just used for desktop, it can be used for a variety of different hardware or software. Very open like that. Also, you don't need best systems. You don't need the best systems to run it. The specifications can be a lot lower. You don't need to go really high end, but there is a lot harder learning curve to using the Linux OS. So about the batch. Operating system is so what batch does is it groups similar jobs or tasks into these batches, and every job in the batch gets compiled at one time, and there's no user interaction. Once the batch starts, it just does it all simultaneous. It can be run offline. It's just once that one batch starts, everything will get done. The intervention is needed for the next batch or next group of tasks to get started out. And there's poor utilization with the CPU in the batch. And as you can see from the image, the different jobs get put into the operator, get sorted into a batch. I mean, each batch will take their time getting compiled or getting done. So about time sharing. So time sharing allows for more than one task to be run at one time. Unlike batch where you have to once the batch is done, you have to go and set up the next one and let that run. Each task or a group of jobs, say there's 5 tasks you need. Each one will get the same amount of runtime per cycle. And at the end of that cycle, the time gets reset. They all get the same amount of time. They all get an equal opportunity. do your task. There's fewer chances of duplication. But since all the tasks are going at once, the task with the most priority may not be the one that gets done at first. So about the distributed OS, it allows multiple systems to connect to a communication network, and this allows for them to have remote access to the system. Each system will have their own CPU and memory and every stuff like this is disk space if they need it. And if one system fails that isn't the communication network, the rest of the system's okay, they can continue what they're doing. And if they but they do need a network connection in before, like if the network goes out, all of them go out, and the resources can be shared between the different systems that are connected to a network. And embedded OS is a specialized operating system that is meant for one task and one task only. It's really not meant for computers. It's more like for tasks and like everyday machinery, like a car brake could have an embedded system because all it needs is that one task of stopping the car. Well, but it gets really efficient and great at doing that task. And it takes less memory to run, but it's more difficult to run, and it's not versatile because it can only do that one task it's meant to do. Can't do anything else. If you want a new part, like if you need a new task, you'll need another system. Okay, so real time OS deals with real-time data. All the tasks are done within a time limit. It can't be fluctuated. The task must be done within that time limit. And there's two types. There's a soft real time and hard. Soft real time is a bit more lenient, like it's not as important. Any delays won't be crucial to any disaster, any failure. But with hard, if there's like a delay or something, that could really result in error or something that's not supposed to happen. And real time's almost error free. It's very efficient when it's working properly. Doesn't get a ton of errors, but that means the systems are very complex, hard to learn, hard to do. There is an extreme learning curve to making one of these systems. Okay, now for the first part of the comparison, I have is Windows, Mac, and Linux, and how I compared it is. I kind of talked about what OSs, some of the OSs from what I talked about that are in it. Talked about the cons and the pros about each window and Mac and Linux. So like as you can see, Windows has time sharing, distributed, and real time. So does Mac. Linux also has distributed system in it, which I mean I can see that with the Windows because everything's done real time. You can connect to a communication network. And the pros to Windows are, like I said, versatile. Anybody can get viruses as a con. Mac with the Mac, it's like easy use, limited use, and like there was just stuff I've talked about before. And now with the main comparison, I talked about each of the five systems. I talked about what the goals are, about number of processes it can do at once. So that's like batch can do one batch at a time with time sharing. Does multiple applications at the same time. Doesn't need a network connection. Does it work with a computer? Is there a time limit? How busy is the processor? And pros and cons and an example. To highlight some of the more interesting or some of the features. Um, like batch, you don't need a networking. There's no really time limit. Does not directly and it does not interact with the computer directly, but time sharing does. And as you can see, an example of a batch would be a credit card statement. Well, time sharing would be a no, it would be an OS that's kind of like Linux. And then as you can see, the process is only busy when a task is starting. After that, the process is pretty, it's not that busy, very relaxed. And the processor for time sharing is busy because it's always switching between the tasks. And now with distribute, I never operating systems the example I prefer. A con has, like I said, network goes down. It does work with multiple computers. It does need a network. It's one of the few that really do need a network connection. Oh yeah, and with goals, I forgot the goals. The goals for a batch is to maximize resource utilization, and the goal with time sharing is to minimize the response time, allowing various systems to connect over a network is the main goal or objective of a distributed uh, operating system. Embedded is creating a fast and efficient system, focuses on one task only. A lot of these, and again, a lot of these don't necessarily have time limits, except like time sharing, real time are the ones that have a time limit that must be done. And then embedded is like cars, but it could just be like any. I love real world things. Real world, um, real world like cars. A lot of things the cars would have. The systems would have one task, so those could be embedded. And then real time is to have executions happen with little or no delay in real time. It works on one process at a time. Doesn't need a network. Embedded or doesn't work with a computer. Real time does. And then the example I gave was like a weapon system because it's complex. It needs to work in real time like the weapon systems do. Yeah, that is my main comparison with all five, just comparing different stats, different features that you each have to see what they all have. And now for my next part, which is to sum up what I feel like each system is best for. And I personally feel like Windows is the best for like game industry or just personal use gaming because there's just a lot of variety with a Windows operating system. There's so much you can do. Mac, for my little use of a Mac, I find Mac's really good with the film and editing. And then Linux, and what I found as I found out Linux is very good or supported, like it's supporting every system. It can do a lot to help debug a system, help like check providers, just a bunch of ever stuff it can really do to help make a system better. Just it's really good with helping ever systems. The batch operating system is really good for banking payrolls as that stuff can be done overnight. Batch can be run offline so you don't have to be there while it's running because it does take a bit of time. Time sharing is good like for anything like phones, laptops, computers. Like only multiple tasks. It's like multitasking if you're gonna be like playing games, listening to music, doing your work. Time sharing allows you to do that all at once. Distributed is good for like online services where you just need to be connected. You need to have some type of connection where you're giving data, taking data. So anything online, which works a lot with the Macs, Linux, and Windows. Embedded is any system that just you need. If you need like one task to be done and you want it done really efficiently and you don't need to worry about any other task being done, embedded would be the best choice. In real time, it's like anything, any complex system that needs it has to be done really quickly without delay. And one example would be like a weapons system you want it to be fast, accurate, reliable, and that's what real-time operating system would do. And my final thoughts are that Windows, Macs, and Linux are all good operating systems. They have their various uses, and they all have their plus and negatives, and the rest of them, each one, they have that one task or a few areas where they are great at, or perfect at. But then again, they do have their downsides, where they're not as good as. We need to look at a different system, but every system I talked about, there's something or multiple things that they are good at, and what I would recommend using them for. And thank you for listening to my presentation.